So this screencast is on how we draw Lewis structures with multiple bonds. I mentioned this in a previous screencast, so now we're going to get into how do we actually draw these. So a triple covalent bond, or a triple bond, is a covalent bond where there are 3 pair of shared electrons. So we see here we can draw this with dots, where we have 3 pair of dots between the 2 nitrogen atoms, or we can draw 3 lines. And recall each line represents 2 electrons being shared. Likewise here with the next example with hydrogen and carbon each share a pair of electrons. That's a single bond, but the 2 carbons share 3 pair of electrons. So that is going to be a triple bond. So we see again, we can draw those as bonds as lines. Double and triple bonds work the same way. So an example of a triple bond would be where you have carbon being combined with each other, and then each carbon is combined with 2 additional atoms. So we can fill in those additional atoms as hydrogen atoms, and we would see that the carbon is sharing 2 pair of electrons, which are represented by 2 pair of dots being shared. So again, we can draw the lines to represent the bond, or we can have 2 pair of electrons or 4 dots between the 2 atoms to represent a double bond. So both double and triple bonds are referred to as multiple bonds, and that's what we're focusing on in this screencast. So when we're drawing Lewis structures for compounds that have multiple covalent bonds, we follow the same set of steps that we did for single bonds. So in this example, we want to draw the Lewis structure for methanol, which is CH2O, and it's also known as formaldehyde. So step 1 is to determine the number of atoms of each element present in the molecule. So if we look at the formula, we know that we have carbon and hydrogen and oxygen. And again, looking at the formula, we know there's 1 carbon, there are 2 hydrogens, and there is 1 oxygen. And then we have to look at what are the number of valence electrons for each element. So carbon has 4 valence electrons, hydrogen has 1, and oxygen has 6. So now we need to do the math. So 1 times 4 is 4, 2 times 1 is 2, 1 times 6 is 6, and when we add those up, we get a total of 12 electrons. So this is the number of dots that we need to have in our finished Lewis structure. 12 dots or 12 electrons. So now we need to figure out how to arrange our atoms. So remember, our formula is CH2O. And recall from the single bond screencast that the atom that's listed first is usually the one that's in the center. So we're going to put carbon in the center, and it has 2 hydrogens and 1 oxygen bonded to it. And then wherever the 2 elements are sharing electrons, we're going to add our 2 dots. So we have 2 between carbon and hydrogen, 2 between carbon and oxygen, and 2 between the other carbon and hydrogen. So our next step is to go ahead and fill in with the lone or unshared pair of electrons for the rest of the atoms. So carbon has 2 more, and oxygen has 6 more electrons. So now what we want to do is we want to count the number of electrons. So recall when we did our math, we needed 12 electrons total in our Lewis structure. So let's count and see how many electrons we have. We have 2, 4, 6, 8, 10, 12, and 14. So we have too many electrons. Because of this, what we want to do is we want to remove a pair of electrons from the center and a connected element. Now we're going to remove this pair of electrons from carbon, and we're going to go ahead and move this pair of electrons from oxygen. Now you need to make sure that the electron pairs that you remove are ones that are a lone pair of electrons that are not involved in bonding. Okay, so we get rid of those 2 sets of electrons, and what we're going to do is we're going to replace them with a shared pair between the carbon and the oxygen. So these electrons, okay, are no longer part of the formula, and they're replaced by those 2 electrons there. So let's redraw this using our structural formula. So we have hydrogen, which has a single bond to carbon, which has a single bond to another hydrogen. And then we have 2 pair of electrons being shared with the oxygen, which has these 2 lone pair of electrons on the side. Now let's count our electrons. Remember, each line represents 2 electrons. So we have 2, 4, 6, 8, 10, and 12. So this now gives us the correct number of electrons in our structure. All right, so let's try this one, CO2. We're going to start by figuring out how many electrons we should have in our finished Lewis structure. So carbon has 1 atom and oxygen has 2 atoms in this formula. All right, I know that carbon has 4 valence electrons and oxygen has 6. So 1 times 4 is 4, 2 times 6 is 12. When I add them up, I get a total of 16 electrons in my valence shell. Now, because carbon is listed first in the formula, I know that carbon is going to be my atom in the center, and it will be surrounded by oxygen. I'm going to put a pair of shared electrons between each of the atoms, and then I need to fill in with the rest of my valence electrons. So oxygen is going to have 6 more, carbon will have 4 more, and this oxygen will also have 6 more. So now I'm going to count my electrons. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I have too many electrons here, so I need to start getting rid of some. The first thing I'm going to do is get rid of a pair on my center atom and a pair on my outside atom. And I'm going to replace them with a shared pair between that carbon and oxygen. So let's count our electrons again. Now I have 2, 4, 6, 8, 10, 12, 14, 16, and 18. I'm getting better, but I'm not quite at 16 yet. So I'm going to remove another pair from my center atom and another pair from the other oxygen, and I'm going to replace them with a shared pair between oxygen and carbon. Let's count again. This gives me 2, 4, 6, 8, 10, 12, 14, and 16 electrons in my Lewis structure. So now I know that my finished Lewis structure is going to have either it can have a double bond between both of the oxygens and the carbon. So it would look like this. We would have an oxygen with a double bond to carbon, with a double bond to another oxygen, and we would fill in with the remaining electrons around the oxygen. We can also write it as carbon having a triple bond to an oxygen and a single bond to the other oxygen, in which case we would fill in with the electrons appropriately around the oxygen. And then this triple bond can occur on either side of the carbon. So the other way we can write this is oxygen triple bonded to carbon, single bonded to the other oxygen, with our lone pair of electrons on the appropriate oxygens. So it doesn't matter which way you write the formula, but you do need to recognize that in every single way we write the formula, there are multiple bonds involved. And so this is important to reflect in your Lewis structure, whether it's using the lines or the dots. Okay, to your notes, I would like for you to add the following homework. Take the formulas that are provided, and I would like for you to draw the Lewis structures for each of these formulas. Make sure that that is included with your notes on this section when you submit your homework.